All right, we are beginning. The recording is started. Okay. I'm replacing this one with my standing up during COVID wearing a mask video. So we have to record. All right, permutations. We're focusing day one, just permutations, the way numbers, and so like day one. Combinations is day two. All right. A permutation versus a combination. Okay. Two things, many things happening at once. How one thing affects another thing. That's the main idea of all this. So here we go. We're going to go through this carefully. Holly, Tia, Kenji, and Nate are eligible to be officers of the National Honor Society. Let's make it NHS, because I love NHS. 2 of the 4 students will be chosen at random as president and vice president. So they're just choosing at random. The table summarizes the possible outcomes. President, vice president. Okay? Holly, like, see how there's a blank space? Because Holly can't be both. Tia can't do both. Kenji can't do both. Nate can't do both. Okay? So those are the combinations. Ready? Holly wants to be an officer with her best friend Tia. Okay. I want to find Holly and Tia. Holly and Tia. HT. Or TH. Holly and Tia. TH. HT. HT. Sorry, there's 2. 2 outcomes. Okay? How many outcomes show Holly president? H has to come first. Tia second. HT. Only one option for that, right? Obviously. How many outcomes have only one of them, H or T, right, as the officer? So anything that has an H and anything that has a T. What's up? All right. Here we go. So each girl could be with the other boys, right? It's going to be HK, HN. She's done. So the girls with the boys, basically. Okay? TK, TN, TK, TN, KH, KT, KH, KT, NH, NT. Right? 8. 8 outcomes. Okay? All right, here we go. So it's easy because it's all listed for us. We just looked at the chart, right? Not difficult. All right, next, factorial. This means multiplying a number by all the numbers prior to it. So factorial, multiply the number times all of them less than it. So like 4 factorial means I go 4 times 3 times 2 times 1. Okay? So it's the numbers under it. So 9 factorial is going to be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, what is that number in your calculator? Okay, would you like to learn the keystrokes on the calculator? Okay, so you press 7. So 7, then you press PRB, probability button. Probability, and I go down to the third option, that's factorial. So there's 7 factorial. On your own individual calculator, I don't know. You would have to play around. But it's under probability online, so maybe if you have a PRB, you can figure this out. Okay. Enter 5,040. Are you guys able to figure it out on your own? Okay. You guys, n minus 4. Okay. Now I'm going to do, it's like -4. You get that? Okay. So the number's under it. Okay. I want to just go, let's have if n equals 10. If n equals 10. That'll be good. So I'm going to go n minus 4, which would be 10 minus 4, which would be 6, right? And I have to go to 1. 6, 5, 4, 3, 2, 1. So then it's going to be 10 minus 5, which is 5. Ten minus 6. So if n equals 10, I'm giving you 10. 4 times 3 times 2 times 1. I'm not going to write it all in. Anyways, that's pretty much the same as that's how you would write it, okay? Until you get down to 1. This second one, these are really rare. They're weird because I gave you something more difficult than just a straightforward number. You guys are talking a lot. I know, but it's on the... Okay, n plus 2. I'm not going to give you a value now. Times n plus 1. That's all I can do because I'm done. All right? You just go down to 1. Go down to 1. And we won't do d. So it's more complex when I give you this binomial n plus 2. But basically, you can't solve you can't get an answer. I'm just showing you what it would be. Okay? So we get down to 1. Yeah.
So if you were to use that, that's the answer?
Yeah, this is the answer. You can't go further. I'm just modeling for you the pattern. So I don't want you to get a number answer for that one. All right, turn the page. I gave you the value of 10. I told you it was 10. If n equals 10.
How do we know what n would be?
Oh, you would be told. You don't ever guess. Okay. All right, this gets a little more tricky. Ready? Fundamental counting principle. There's m ways to make a first selection and n ways to make a second selection. This happens in life with patterns of, the first example is a license plate. Okay, so the standard configuration for a license plate is a numbered lead off, followed by 3 letters, and then 3 numbers. 7 digits is license plates. There's a number, and then letters, and then numbers again. Okay, ready? So let's go through this. And I want to say, all right, how many different license plates are possible if the digits and letters can be repeated? You guys, how many numbers are there that I could have on a license plate? What are the choices? Could I have a 0 as a number? Yes, zeros are on license plates. And you go up to 9, right? Okay, that's 10 options. How many alpha letters could be on a license plate? How many alphabet letters? 26, thank you. Okay, here we go. So here's what you got. A number, letter, 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 number, number, number. It's 7 digits, right? There are 10 options for, sometimes it doesn't start with a 0. I don't know whether I've ever seen a license plate begin with a 0. So we might be able to say there's only 9. I've never, of course I can't remember offhand, but it's not likely. Letter, 26. Letter, 26. 26. 10. 10. 10. Okay? This is if they can be repeated. All right. Anyways, I'll just tell you guys. It's 175,700,000 options. Okay. You would just multiply 10 times 26 times 26 times 26 times 10 times 10 times. Got it? All right. How many different license plates are possible if the digits cannot be repeated? Ready? Number, letter, letter, letter. Number, number, number. Okay. I cannot repeat. So I'm not going to have 10s and 26s all this time. I'm going to have, okay, the first is fair game, 10 numbers total. And then the second is 26 alphabet letters because I'm not repeating. But now on my second letter, what number do I put? Because I've already used an alphabet letter. 25. Now I've already used 2 alphabet letters. What number do I put here? 24 times number. Now, right, I've already used a number. So there's only 9 options left, 8 options left, 7 options left. Okay. Can you guys multiply those numbers, please? You're going to get a giant answer.
28,624,000.
You go.
78 million.
Oh, okay. Okay, Judy.
That's what I thought. I'm not loving this attitude right now, Jaden.
Yeah. Yeah. All right. You guys, what's my answer? I'm still recording, guys. I got to stay on task.
78,624,000.
Yep, that's what I got too. Good. Okay. Now we're going to talk about permutations where order does matter. The ordering does matter. Ian, can you? Okay. The arrangement of objects in a specific order. How many ways can you arrange ABC? Do that on your paper. I want ABC to be arranged in as many different ways as you can. Go.
Okay, miss. Can you follow his OBCA. Oh no.
Okay, ready? How many did you get? 6. You're right. ABC, ACB, BAC, BCA, CAB, CBA. We good? Okay. Now, we are multiplying to get down to 1. Remember, get down to 1. That's why 1 is at the end. Okay? So you're just going to go 3. It's 3 factorial is the answer to this. 3 times 2 times 1. Okay? That's mathematically how you do it. So now, the number of distinguishable permutations in n objects where one object is repeated, another is repeated, and so on. So this would be like, I'm going to give you an example. Here's the word peppers. Okay? Green bell peppers, red bell peppers, whatever. Here we go. The letters repeat, right? And we divide those out. Okay, here we go. How many letters total are there in peppers? 6. 7. 7? 7. So n is the number, like the total number of letters. That's on the numerator. Divide the letters that repeat. What repeats and how many times? P repeats. How many P's are there? 3 factorial. So I put that P repeats 3 times. There's 3 of them. I divide them out because they're repeated. What other letter repeats? E. There's 2 of them. So you put a 2 in the denominator. What's the answer, guys? Do it on your calculator. What's the answer? 420. Good job. Okay, ready? How about the word class? Try that one on your own. Class. Total numbers on top, repetition ones on bottom.
How are you going to not support your brother in this? If it was me, would you not? Not if you're in the banquet, like if it was like $10 per person. I don't know why. I know how to
Okay. 5 factorial divided by 2 factorial because the S repeats, yeah? Here's a way that I did, like, if you don't have a calculator, here's what you do. 5 times 4 times 3 times 2 times 1 divided by 2 times 1. Since these cancel out, right, all you really have to do is 5 times 4 times 3. All right? Just wanted to point that out. Okay? All right. So this is repeated, okay? Now number 3 is totally different. The number of permutations, I need the side conversations to be quiet. Table 6. Because it's loud on the YouTube video. Like even right now, it shouldn't even be talking like this on the YouTube video. Okay. The number of permutations of n items arranged different times. Okay, so this is a notation. It's called a permutation notation. Okay? You will be given a math problem that would look like this. Okay? 1 value is on the lower left, 1 value is on the lower right. I'd give you this problem, and I'm going to teach you how to solve it. Here's what you do. So, 7, this means 7 items arranged 3 ways. Okay? 7 items arranged 3 ways. Here we go. You're going to put the total number of items on the numerator. 7 as a factorial, please. And then below it, I'm subtracting. So it's basically the left minus the right. Get it? So 7 minus 3 first, and then do that factorial. So it's 7 factorial over 4 factorial. Ready? I'm running out of space. 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Cross, 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 cross. You're really only doing 7 times 6 times 5. Okay? So crossing out is simplifying. I want you to do that ahead of time. Because there's no fractions in your calculator for factorial. Right? All right, 7 times 6 times 5, 210? Cool. Let me jump to C because I just don't have space for B. 9 factorial divided by 9 minus 2 factorial. Get it?
You know the UCC. Why that?
All right. Answer is what?
Party school?
It's really, you're only doing 9 times 8, huh? 72. Okay. Moving on. Can I move on? Well, you should have been doing it on your own when I gave you quiet time. All right. 12 skiers are competing in the final round of the Olympic freestyle aerial competition. Aerial is when they go in the air and do like a flip or something. How many different ways can the skiers finish the competition, assuming there's no tie? Okay. This is simply straightforward 12 factorial. Do the shortcut to factorial on your calculator, please. I want to see it.
Big number.
It's 479 million and 1,000.
Free. You're free. You want to go out of state?
All right. Ready? 479 million. 1,600. Yeah? Okay. And now, this is getting complicated. In how many different ways can 3 of the skiers finish first, second, and third to win gold, silver, and bronze? It's going to look like this. Total number goes on the lower left. My desired, what I'm trying to find, 3 of them. So that's the setup. Okay. Now, if you recall from the page before, it's going to be 12 factorial on top minus 12 minus 3 factorial on the bottom.
So it'd be 12 factorial divided by 9 factorial?
12 minus 3.
What's one thing that money is?
Okay, guys, what's the answer?
Money is
Remember, you're really only doing 12 times 11 times 10, aren't you?
money equals power.
Because the 9 and lower cancels out. Yeah? What'd you get? 12 times 11 times 10 is all you're really doing.
1,320.
Okay, good. We're almost done, guys. Just these last 2 and we're stopping. Okay? You are considering 10 different colleges. That might be you because you guys are so darn smart, huh? Before you decide to apply, you want to visit some or all of them. In how many? Too much side conversation. In how many different orders can you visit the 6 places? So, the 10 places. You want to visit 6 of them. Here's the setup. Ready? 10 is the total that's lower left. Your desired, what you want, goes on the lower right. This is a subtraction one, right? 10 on the numerator. 10 minus 6 on the denominator. Really, it's only 10 factorial over 4 factorial. Okay. And the answer is what? 151,200. All 10. Straightforward. It's just 10 factorial. Okay. 34,000. Oh no. Oh, okay. 34,650. Something moved over there. It blocked out for a second, but it's still recording. That's fine. Okay, last question. This is not a subtraction down below. Okay, this is like here. Distinguishable permutations. So on the numerator is your total, and on the bottom is the ones that are repeated. We already did pepper, so let's do Mississippi. Remember, it's N on top divided by the like the repeated. I'll just call it Q1, Q2. That's what I called it on the front. This is not subtraction. This is back to repeating. Peppers in class. Remember peppers in class? Mississippi. Mississippi. How many alphabet letters are in that word?
11.
Okay. On top goes 11. Okay. Denominator. I want to know the repetitions. And I'm going to multiply those two at the bottom. So I know that S repeats, I repeats, and P repeats. How many S's are there? 4 factorial on the bottom. Multiplied by, how many I's are there? 4. Who came up with this word? Like, seriously. Maybe it's some man's last name.
Mr. and Mrs.
From like 1803. Who knows? What's P? How many P's?
2.
All right. This is trickier because on your denominator, like, you can delete out one of the 4, 3, 2, 1s from the top and bottom. Like, I can. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 5. Okay. You guys, there it is. I can delete out one of the 4s, right? But I still am going to have underneath a 4 times 3 times 2 times 1 times 2 times 1. Get it? So one of the 4s was able to clear out, simplify out, but not all. Okay? So on your calculator, you actually have to enter these numbers in. Get your numerator, get your denominator, and then divide after. Go slow. Okay. Whoa. Sorry. What is it? What is it, guys?
Okay.
Work it out. 34?
34,650. Oh, let's go.
Awesome. Perfect.